Hi everyone. In this video I want to go over an example with you that shows how you can use MM2 to figure out the cost of equity when a firm is undergoing some sort of a change in capital structure. But perhaps more importantly, I want to show you that MM2 is not saying anything radically different from what you may have seen before in terms of how a firm's unlevered beta or asset beta is related to its equity beta and how that equity beta translates into a cost of equity. All right. I know I said quite a bit, but let me try and explain this using an example. And for exposition purposes, I'm going to assume a perfect world or a world with perfect capital markets. All right, so suppose that there's an all-equity firm with a beta of 1. Okay, so it's an all-equity firm. That means that if you draw the balance sheet, on the left-hand side you have assets, and on the right-hand side you just have equity. Assets have some beta, which is the underlying asset beta. We also call it the unlevered beta. Equity beta, we usually denote with the symbol beta S. And because it's 100% equity funded, asset beta and equity beta are the same in terms of magnitude. So I'm going to write this down. Asset beta is the same as equity beta right now, which is 1. All right, the risk-free rate and the cost of debt is 5%. This is important. We are in the perfect world of Modigliani and Miller. So the risk-free rate is the same as the cost of debt, although there's no debt right now. But if the firm were to borrow, it would borrow at the risk-free rate of 5%. You are also told that the market risk premium is 6% and there are no corporate taxes, so taxes are 0. The first question is calculate the cost of equity. Basically right now the firm is entirely equity funded, so there's no debt, so the only capital is equity. So saying whether we want to calculate the cost of capital is the same thing as saying we want to calculate the cost of equity. And every time I say cost of equity, you should say CAPM. And CAPM says that the cost of equity, RS, can be calculated as the risk-free rate plus the beta of the equity holders, which represents their risk, times the market risk premium. And because in this case, the risk-free rate is given as 5. And equity beta, mind you, in this case is the same as asset beta. So 1 and market risk premium is 6%. The cost of equity comes out to 11%. The important thing here is that this is a very specific cost of equity that only prevails when the firm has 0 debt. We like to call this the cost of unlevered equity. And because it is a unique point, we often denote this by the symbol R0. All right, so part B. Suppose the firm moves to a debt to equity ratio of 0.5. What's the firm's weighted average cost of capital now? Rather than saying cost of capital, I'm now saying weighted average cost of capital. Means the same thing, but the point is that now there is going to be some debt. So the firm is moving towards part debt, part equity. Now there are 2 ways you can do this kind of a problem. One is not using MM2, and then the other is using MM2. One point of this exercise is to show you that in this perfect world, in this setting, it doesn't matter how you do it. In fact, I want to do it both ways so that you can see that both methods are somewhat equivalent ways of doing the exact same thing. So if you don't want to use MM2, this is how you typically do the problem. You say, well, because the firm now has debt, equity beta is now going to be more. In fact, we know that equity beta is 1 plus debt to equity ratio into asset beta. And because the debt to equity ratio is 0.5, so 1 plus 0.5, and asset beta was given, which is 1. So the new equity beta is going to be 1.5. And once you have that, then you can now plug this equity beta into CAPM and say the rate of return that equity holders are going to want is RS equals to the risk-free rate, which is given in this example 5%, plus the new beta is 1.5 for the equity holders times the market risk premium, which is 6%. So if you do the math, this will come out to 14%. That's one way of doing it. Except MM2 says, that's too much work. I don't want to first compute the beta and then plug it into CAPM. I wish there was an equation which could directly tell me what the rate of return is that the equity holders would want if leverage went up. And that is exactly what MM2 does. MM2 says the rate of return that equity holders will want will be equal to the unlevered cost of equity plus B over S into R naught minus RB. Again, if we are living in a world without taxes, there's no taxes or anything in this equation. And R naught, what is R naught? R naught is the rate of return that equity holders want in the absence of any leverage. We know what that was. This, based on our math, was 11%. And now, because the debt to equity ratio is increasing to 0.5, without having to compute the underlying equity beta, we'll say, okay, then 0.5 times R naught, which is 11%, minus RB, which is, in our example, the risk-free rate, which is 5%. You do this math, you will get exactly 14%. And that was one of the key points. That the cost of equity, whether you do it this way, whether you do it MM2 way, the cost of equity comes out exactly the same. We're not quite done, because question was not what the rate of return is that the equity holders want, but rather what is the weighted average cost of capital now. Well, that part is easy. The weighted average cost of capital is B over B plus S into the cost of debt plus S over B plus S into the cost of equity. Notice I don't have a 1 minus T in this formula because we are in the perfect world of Modigliani and Miller. There are no taxes. This is 5%. This, we now know with leverage, is 14%. And we know that the debt to equity ratio is 0.5. If the debt to equity ratio is 0.5, that means that the debt ratio is 1/3 and the equity ratio is 2/3, right? Because debt is 1/3, equity is twice that, so that 1/3 over 2/3 is basically half. And so now just plug in these numbers, 5% here, and then 2/3 of 14%. Actually, while you do all that math, I can tell you that this is going to be exactly equal to 11%. Notice that we are in the perfect world of Modigliani and Miller. And what did Modigliani and Miller say? That in the perfect world, changes in capital structure will have no impact on the weighted average cost of capital. This number comes out 11%, which is exactly equal to the unlevered cost of equity that you saw we got earlier as well. If you found this video useful, click the like button and subscribe to the channel. And feel free to ask any questions using the comment section. Happy learning!